Welcome to Events and Interaction. Now we go to the second principle of interaction programming, which is listening to events on the tree nodes and also updating the tree based on whatever the meaning of the event is. Let us start from our number editor, and what we want to do now is to add an event listener on this minus button. And to do it in the console, we just click on the button and we see that the browser says that the element we click on is noted $0. So we define a constant with that. The other thing we do is we prepare what we call an event handler or an event listener, which is a function which simply prints its single parameter. Then what we do is we associate the listener here minus clicked with a click event by using add event listener on the minus button. So this means that whenever there will be a click on the minus button, minus clicked, the function minus clicked will be called. Note that I'm not calling the function here, I'm just passing it to the minus button. Then when we click on the button, we see that the mouse event is printed out. What we also can see is that if we click on event listeners here, we see that actually we have the event listener that we just added. We can also look at its source code, and we also have the option to remove it if we want. The other thing we can do is we can add a breakpoint in the event listener, and then let's say that we want to investigate what happens when the event fires. When we click, our code will pause. It's also important to note that the browser warns us that our event listener took a lot of time. Well, in this case it took a lot of time because we had a breakpoint. But normally event listeners should finish pretty fast, so they shouldn't do a lot of computation because that would affect the user experience. Basically the interface is unresponsive while the event listeners run. If we now generate an event and expand it, we can see that there is a lot of data passed in the event object. It has many properties, many of them very interesting. For example, we know whether the Alt key was pressed at the same time when the mouse was pressed to generate the click event. We also can find out about the control key and many other details. This is a very general principle in interaction programming. We can say that if Alice wants to be notified of changes by Bob, Alice gives Bob a function. Then whenever Bob wants to notify Alice, Bob calls the function. We say that Alice subscribes to Bob and Bob notifies Alice. Often more Alices can subscribe to one Bob. So here is the timeline. Alice calls some sort of method of Bob called subscribe, passes a function, a callback. Bob now and then invokes it. At some other point Alice unsubscribes, and then from then on Bob will not say anything. There is a bit of more advanced version of this where Bob calls the function with a parameter which is called payload or event, which is also the case for add event listener. The browser passes an event, or the graphical toolkit we use will pass an event with lots of details, as you have seen. It's important that function is just a declaration, not an invocation. And then subscribe, as you will see through the course, has many names depending on the situation. It can be add event listener like we had, add observer when we use observer observable. It can be called then and catch for promises. What we want to focus on now is the target. The target of this event is the minus button. It's the node tree on which the click event has been fired. And that is not at all surprising. because that's where we register the listener. But if we register another listener, another click listener on the div, the parent of the minus button, we can simply register it to print the target. Now we see that we first get the minus event, but then we see the target printed by the listener on the div. And that's because the first event is fired on the button, and then it bubbles up the tree. So both the button will get it, the div that contains the button will get it, and the body that contains the div and everything else will get the event. One more thing to say about events is that some are a bit higher level than the others. For example, the click is made by a mouse down followed by a mouse up event, or it can be made by a keyboard focus when we press, for example, tab and get the keyboard focus to the respective button, followed by a key down with either enter or the space keys. Events are easily supported in Hyperscript and JSX by using an on event name property where we're supposed to pass the attributes. In that case, the Hyperscript engine will not end up doing a set attribute, but it will end up doing an add event listener. We would now like to make our interface interactive by changing this text node when one of the buttons are pressed. For that, we add some listeners, and each listener is going to update the text node when the event comes. Here we have the number editor that updates itself incrementally. The minus button is looking at its next sibling, and it's decrementing the number and putting it there. The plus button is looking at its previous sibling, increments the number, and sets it to that node. And we see this working nicely. And we also, if you watch this node updating, you see that that's the only thing that changes in the tree when I interact. So that my update is indeed incremental. Let us imagine that we would like to have one more element in our interface, an input box. And we would like that input box, of course, to be always synchronized with the rest of the interface, but also should be able to change the number to an arbitrary value, not just +1 or -1. The input box would listen to a change event, and when the event comes, the input box then needs to change the number. The trouble is now that in order for the input box value to stay in sync with the rest of the interface, also the minus button and the plus button need to update its value. And that is, of course, very hard to maintain in the long term. The alternative to incremental update is to re-render parts of the tree, such as components, completely. Basically, when some event comes, we see that some data is changing, like the props of the component are changing, which tells us that the component is not anymore up to date. So what we have to do is to, after we have updated these props, to remove what was there before, remove the place of the component in the tree, re-render it with the new data, with the new props, and then put the result back into the tree, into the DOM, into the browser DOM. One way to implement this is using custom events. In custom events, besides the number that the number editor needs to display, we also pass a callback as a prop to the component. And then that prop means that somehow the component wants to change the number. So it calls that function whenever it wants to call to change the number. And as you see here, the buttons are calling it with plus and -1, and input box is also calling it. So all three event listeners are quite similar then, but the value is interesting here. We have to take the event target, which we know is the input box, and from it we take the value property. And this is one of the rare cases where we still need to use node properties rather than node attributes like these. Let us see how the custom event can be used. In this case, we will use it to actually refresh the component in the DOM after a re-render. When we initialize the component, we pass as setNumberProp a function, and that function happens to re-render the component and then replace its old content in the DOM with the updated content. I test my new version of the number editor using a custom event. Everything works. Also the text or the input box works. But if I look at my tree here, I see that there are dramatic updates in the tree because of replace child, which produces big changes in the tree. To address this problem, frameworks don't actually do replace child. They compare the re-rendering with whatever exists for the component in the browser DOM and only update in the browser the differences. And you see here a simple implementation of that using a reconciliation library. Basically now you see that only the smallest possible changes are made to the browser DOM. Let us compare our DOM events with the custom events. In the DOM event, the input box used by, for example, the number editor will get a change event listener, will get this function, then it will call it with change events as parameters. The button event, a similar situation, gets for click events, gets this callback, and then it invokes it to notify with click events. The number editor, code using it, is sending a property, a prop called setNumber, and that's the way it subscribes. And then the number editor calls that function, but not with events, but with numbers, which is probably much more useful for the outside world than to get events and having to look into them and analyze them. We could say that the input box fires change events, the button fires click events, and the number editor fires setNumber events, so to speak. That's why this is called a custom event. The other thing we have to notice is that basically, if we look into the code, the number editor takes input events and converts them to setNumber, and takes click events and converts them to setNumber. That is, we convert the event to something higher level, more useful for the outside world. To sum up, we have looked at how events are supported in Hyperscript and JSX. We will use a lot subscription and callback in our code in different ways, not just for events. Custom events are important, and the idea that our interface is re-rendered, and the reconciliation. Also, we have seen that at least to interpret input events, we need to look at the value property of the respective input, which we get from event target.value. Those type of properties, although we use mostly attributes in interaction programming nowadays, this type of property like value for an input box, checked for a checkbox, and so on, those we still need to read from the DOM. Thank you.